Hello and welcome. So this is a guide to creating sampler style instruments or Kontakt style sampler instruments in Max for Live. So to begin with, you can see I've got Pro Tools open here, and so what I'm doing here is I am just recording in bass guitar. So to get the sounds up, I'm just running through this, which is Brainworks Ampeg SVT. And what I'm going to do here is essentially just play through every single note on the guitar. So starting with an open low E and then just going up semitone by semitone. So here I am recording those. So for some Kontakt style instruments you'll do multi-samples, so multi-velocities, but for this basic one all I'm doing is just semitone by semitone. So in Pro Tools I've just used Beat Detective here, just to be able to seek out transients, which allows me to cut right on that transient. So as you see, I've now got loads of separate clips, so I'm just fading those in and out, making sure that I've got no cuts or no clips. Once I've done that, I can do these batch fades, as you see, and that results in some nice clips like this. I'm just double checking here that they're tailing off properly. And then once I've done this, you'll see next step would just be to just make sure the sound is exactly as I want it. So I've put here a 1176 style FET compressor. So this is one from Black Rooster Audio. I've also used the maximizer in Ozone just to make sure every single note is playing out at the same level. Then once I've done that, what I'm doing here is just then recording into Pro Tools through that track, so that I've got the SVT, the FET compressor and Ozone printing onto that track. So it's all recorded as I want it to sound. So I'll just jump through clip by clip, as you see, just bouncing in place. If only it was this quick in real life, not sped up. So I'll end up with every single note on the bass guitar, which starts from a low E, goes through several octaves, and as you'll see, this shouldn't take too much longer. Every clip's looking like it's a nice similar level. So the next step then would just to make sure that we're dragging these audio files out and we're storing them somewhere that we can access. So just through the audio bin in Pro Tools folder, I've found those samples, so I'm going to put them here into a bass samples folder in my main root folder. I'll jump through then, and as you can see, just rename all of these so they're relevant to the right notes. So I'm also putting there the octave range as well, so you can see it goes from E1, E2, so on and so on. So once they're all named, we can then start working in Max for Live. So to do so, I'm going to drag in a Max instrument. So because this is a sampler instrument, it needs to read MIDI and then output audio, so the Max instrument is what we want for this. So usual things, let's just start off, we'll drag the MIDI in and plug out just two areas of the patch that gives us a bit of space. So we'll start with a note in and just hook this up to MIDI, and we don't really have to do this, but it's just a good fail-safe. So note in is going to allow us just to break up that MIDI message into pitch, velocity, and if we need it, channel, but we're not going to use channel here. So I always just like to put these integer numbers here just so I can see that the MIDI messages is passing through. So the top one you see is pitch, and then the lower one here is for velocity. So this is good practice as well, so I'd always recommend just labeling things up as you go, because when you reopen these patches several weeks down the line, or several years down the line in some instances, you actually understand what you're looking at. As you can see, these are the notes coming through. So I've written down here some key objects that we're going to need for this device. So feel free to freeze frame and grab this. But to start with, we're possibly going to look at pack. As you can see, it combines and packs data messages. So the reason we're going to do this is because we're routing signals off in certain directions based upon the pitch number. So essentially we're going to trigger certain samples that we've created based upon the MIDI note pitch. So packs together then pitch and velocity into what Max calls a message or a list. Yeah, and as I say, we can then strip this first number off that list to send to a certain direction. So you see I'm just typing here. The argument is always quite important in Max. So the argument here is 0 space 0 is telling it to read 2 integers on that input. So if there were floating numbers, there would be 0 point, 0 point. So we just hook those up. Let's just put on a message here just so we can read what's coming through. So you can see now a list is being created. So this is quite interesting. You can see now there's a velocity for a note on and then also a note off. So we'll get to that in a sec, but that's something important that we'll have to look at. Okay, so from here then we can actually send velocity values in certain directions based upon their MIDI pitch number or their MIDI note number. So the way we're going to do that is with this root object. So again, feel free to freeze frame that and grab that text if you need a bit of guidance on what root does. So I'm going to route things based upon the sample notes that we've created. So as you can see here, we are just double checking what E1 is in terms of MIDI note. So E1 there was 40. So whenever the key for E1 on the keyboard is played, it's going to route it out through a specific output. So here I've just created just enough information just to get started, so we'll probably add the rest of the octave there. But as you can see, we're going to create all the MIDI notes here for the first octave. I mean, you could do all octaves in one route, but I wouldn't recommend it because these root objects are just going to end up getting very, very big and ungainly. So I just do the first octave, which is E1 to D sharp 2, or MIDI note number 40 to 51. So see, I'm counting, I've got the right amount of notes in there. So if we hook up, yeah, you can just double check here. So D sharp should be 51. So you can use this diagram as well. So feel free to freeze frame this diagram if you can double check. Notice as well, Ableton is an octave out from standard MIDI in what you'll find in Logic and so on. So as I'm saying here, the last outlet of the root objects, if you actually count the outlets of root, there are actually one extra, so there's 13 there. So the last one's always an overflow. So if something isn't matching and it's still in the list input, it'll output through that last outlet. So here we can put on, for example, the second octave or the third octave, and then keep cascading. So here we want E2 52 to D sharp 3, so we'll just add in those numbers here. Lovely stuff. And we can keep going. So if you're doing a sampler instrument for, say, a piano, which has got way more octaves, then you can cascade several roots together. So here, because for a bass guitar, it's only got 3 octaves. So we're going to go all the way up to D sharp 4. So ignore those last 2 files there, things have just got a bit out of order. So create our last root. We'll go 64 all the way up. Again, you can look at that diagram, just double check what the last note number should be, or you can just count up 12, and then again cascade that output. So there we have it. So quite nice, quite neat. We can then actually sub-pack these as well, so we can do sub-patches, so it gets a much tidier octave per octave. Also for debugging, if you find issues on certain notes as well, it becomes a bit easier if you're just doing it in an octave. You're looking through 12 notes rather than 3 octaves, which can be a bit of a headache. So again, I'm just labeling things up so I can just see what's going on later on. So it's not just guidance text for you guys, it's also guidance text for myself. It's always good just to double check. Okay, so the next step then is we're going to create the way that individual samples are going to be played back. So essentially what we're doing is we're creating a playback device for each separate note. So rather than the synthesizer that has a pitch generator and it creates a frequency in hertz for it to generate, instead this plays back a pre-recorded sample. So you can see I'm just testing here, so every time the input there reads 40 on the first part of the list, you'll see it sends the velocity out to that specific outlet, and then 41 to the next one, and so on and so on. So that's just me just double checking it's working. So again, debug as you go along. It's always best to just double check that things are working as you're going along, rather than a little bit down the line and suddenly you're scratching your head as to why a certain thing's not working. So here we are, we're creating buffers now. So if you want more information on buffers, always use the help files. So hold the option button or alt button and click on the object, and it'll tell you a bit more about what a buffer does, what arguments it accepts. But essentially here we need to create a buffer for every single one of those samples. And we're going to send a read message to it. Okay, so we can tell the buffer to read a specific audio file if we put the information of that audio file in the read message and connect it to the buffer. Now there are some stipulations to this for it to actually work. So here I've loaded up this buffer and you'll see it's not actually reading any audio data. So file management is massively important here. So the reason for that is because it needs to all belong in the same parent folder. So in Macs you can create packages where we can store audio within, and you can consolidate things down. But because we're sharing files specifically for what is an assessment here, it's easier to create a parent folder and then just make sure all the assets are in that parent folder. Okay, so what we're going to do now is we're going to make sure that we're saving this AMXD file in the same location that all of our audio samples are in. Okay, so this then essentially says, right, well, whenever you're looking at a read message, always look within that parent folder. So let's create a new folder for this, so a bit of file management now. So this will be our sort of package, so to speak, or a pseudo package for this instrument. So I'm just calling it Kontakt style bass, but I'm going to throw in all of those audio samples into this new folder. So I'm just copying them here, so I'm not removing it from that folder, but I've just copied them in. Okay, so they're all in there, and then what I'm going to do is I'm going to save as, and I'm going to save in that same folder. So let's name our AMXD file, so we'll call it the same thing. Kontakt style bass. Okay, now if we hit that read button again, and then double check the buffer. Okay. Click. There we have it. So the audio file now is preloading, so it's reading in that parent folder and it's able to find it. Lovely stuff. So we can duplicate that off and we can just change that message for every single note. So you see this is a bit time consuming. So great, F1, load that up. You can see that one is now loading. If we do this also for F sharp. And that one's loading okay. Lovely stuff. Okay, so one issue that will happen now is that every time someone launches this Max for Live device, it won't automatically read these. So they're messages that need to be triggered. And so we can automatically trigger these messages by using a load bang. So when this patch gets launched, it triggers that read message to read. And and the buffers are automatically filled. Okay, so this is just me adding that load bang to these. Okay, and then we'll just duplicate this off and we'll copy this over for every single one of these notes. So you can see this is the most time consuming part of this really, is just all the sort of data file management stuff. So there's an octave, let's go through and change up to the next octave. If only I could work this fast in real life. Okay, and then finally the third octave. Okay, so we can double check all of those are loading. Right, so now we need to design the system that actually plays back from these buffers. So the audio is stored within the max patch now, we just need now a device that will read back from it. Okay, so we've got the buffer, now we're going to use the play. So play is a nice useful object that whenever it's triggered or told to do something, it will play back from a specified buffer. So for example, we can say play and then E1. Okay, and then this object will play back on demand from E1. So if we hook this up to plug out, for example. Okay, and we need that start playback message. Okay, so this is the way that the play object works. So again, always double check help files. So 1 tells it to play. So if we hook a 1 message up, that will then play back. Wonderful. So now hopefully you're starting to see where we're going to go with this. But what's best is let's get a sort of perfectly designed single note and then we can duplicate off for all the rest of them. But the most important thing is the play object needs the 1 message to start playback. But one thing you will have noticed is that when I play a note and then release it, it triggers it again. Okay, so we're going to get a double stroke every single time. And the reason for that is that that 1 message is being triggered every time a value gets sent to it. And the way note in works is it doubles as both a note on message with a velocity, but then also a note off message when the key is released. And so it's giving it a double stroke. Okay, so there are many ways that we can fix this. But this is just one that I've come up with. Okay. So to avoid both these notes triggering, we're going to use some sort of filter. Okay, so we're going to filter out what is the velocity and then what is the note off. Okay, so note off sends a 0, so essentially we can just use a filter message that whenever the threshold passes 0, it doesn't get sent, or it does get sent. Okay, so 0 essentially gets filtered out. So like I say with all of this, there are many, many ways to do this, so don't take this as gospel and the only way to solve this issue. Max is a wonderful platform that allows you to sort of work out these algorithms. So we're going to use threshold, I think, or we're going to use pass. So again, use the objects sort of search bar there as almost like a Google search to find the correct objects. So I needed threshold, so I typed threshold in and I looked through exactly what I needed. So passed was the object that I needed here. So if we put this in the signal path and double check, yeah, so now it's only playing single strokes. Wonderful. Excellent. So now we have a single note playing back. Let's look at an envelope. So currently it's just playing the sample at one fixed velocity. It's not at the specified velocity, and it's not, got the envelopes that we're able to, as a user, select. So usually in Kontakt, you can change the attack time, you can alter the release. So we're going to use ADSR here. So again, open up the help file. I like to paste this stuff in because it's just preloaded with all the correct arguments. So the way ADSR works is it generates its own envelope, which we use as an amplifier. Okay, so we'll use one of these signal multipliers. In one input the play will enter, and in the other input the ADSR will enter. So essentially what's coming out of the ADSR is the signal, hence the tilde, that's telling it's a Maximus P object, but it's essentially acting as a line amplifier. So we connect them up like this. I'm a stickler for things lining up, sorry about that. Okay, and then what we need is to tell it somehow an input message. So what's going to trigger that ADSR to start. Okay, so the way it starts usually is with a velocity value, and then it will read the note off to say, okay, well that envelope's starting to close. So if we just hook everything up like this, so we can take it feeding straight from that route. Okay, so that's now triggering it. Now notice there's absolute distortion going on here. That's because if we hook it directly up like this, it's going to read a MIDI value, which is from 0 to 127. So if you hammer that key, you're going to multiply the signal output by 127 times. That's obviously going to distort it. So we're just going to scale this down. We're going to use a simple scale object just to read the input that would be 0 to 127. And then instead of outputting all the way up to 127, we're going to output in a range of 0 to 1. Okay, we'll do that in floating values so that we get the decimals. So here we are, 0, 127, 0 dot, 1 dot. Okay, so we'll just throw that into the signal path. I'm just putting these up just so you can see what's changing. Okay, so there's your MIDI value in, and then there's the scale value coming out. Okay. So again, always use things like messages, integer numbers, floating numbers. The print message is also really good, just to do some debugging as you go along, just double check that things are working. Okay, so this should now have the correct output value. There we go, it's no longer distorting. You see we have a set release time, we can change the attack time. There we go, so you can hear the attack is slower. And that release time is opened up. Okay, so that ADSR is all working. So, where next? Okay, so as I say that, so now we've done this for one note, we've now got essentially a working mechanism here that we can package together and duplicate. Okay, so we're going to do this by creating a sub patch of this specific section. Okay, so do keep an eye out about what I'm putting into this sub patch, but I'm going to highlight it and then use the shortcut Command-Shift-E just to then encapsulate and create a sub patch. So we're going to create some sends and receives for these attack, decay, sustain and release controls, just so that we can have one specific set that controls all notes. Okay, so I'm just going to move these off, and then we're going to create some sends and receives. So receive attack, and then change that to send. So then we've got our attack there, and then we'll do that for decay, sustain and release as well. So you'll see I'm duplicating the send and returns that I create, just to make sure that the naming conventions are exactly the same, because you don't want any small little change to occur, because it can upset the system. Right, so here, let's think about how we're going to package this together. I'm going to create an inlet. Now the reason I'm doing this is just to make sure that it's just reading in from one input. If you encapsulate, otherwise it can create two inlets. This is just streamlining, essentially. So let's select the things that I need. And Command-Shift-E, that's now encapsulated. We can delete that inlet and then just connect it up like so. So that is nicely sub-patched. Let's now name it E1. Okay, so if we open it up, so hold command and double click, you can open up that sub-patch and just double check that everything is inside. There it is. Lovely stuff. Okay, so simple process now of just going through, changing the names, connecting them up. Let's just create a multiplier. So I'm going to add a multiplier here with a slightly lower output, just so that we don't end up distorting the output. Doing this as well saves me having to do the left and right every single time. So in each sub patch, we just need to make sure that the play object is reading to the right buffer. So I'm changing where F1 is. That's now reading to F1. So you can see that's playing F1 from the buffer. So they're not repitching, it's playing those different samples. So we'll do the same for F sharp. Lovely. G. G sharp. Wonderful. And A. Wonderful. So actually this is getting a bit long-winded having to create that line every single time. So actually let's create a send. Oh, in fact that's a bit yeah. So we'll shorten the name of that send as well. Bass note out seems a bit long. I like to be streamlined, so BN out. Wonderful, so we can just hook that up to each of these sub patches. So every time we duplicate these, basically, it saves a job. So I'll just duplicate these. So on and so on. So now I can just grab that send and the sub patch and copy that and change. And keep going. So we'll zip through and we'll do the entire octave. Wonderful. So that should now play the full octave. Wonderful stuff. Okay, so we can now actually encapsulate that down with that root object. Command Shift E. Now we've got octave 1. Excuse the typo. Lovely. So you can see straight away we're getting a bit tidier with the way that we're patching. So we'll then do that same process for octave 2 and octave 3. So let's just tidy up this patch. Yep, that's all looking good. Okay. So what I'm going to do is just grab one of these again. Paste this in here. So then this will be E2. So same process again. I'm going to go through sub patch. I'll create them for each one. So I'll create them first this time and then I'll go through and I'll change the insides. Okay, so E2, F2, F sharp 2, so on and so on. See, what looks like it could be fairly complicated is actually quite straightforward. You're just doing the same thing multiple times. Then we have octave 2. And again, we will encapsulate this. So we have a nice clean sub patch for octave 2. We'll call it octave 2. Enter. There we go. this is. Okay, and then we can do the same thing for here. Change the names. Change the play objects. Oh, wouldn't it be good to speed things up in real life like this? But there we go, octave 3 all encapsulated, and there is our 3-octave sampler instrument. God, was that nice and easy? Okay, so we're going to think about a GUI now, a GUI. But let's just tidy up this patch a little bit. So we've got all those buffers as you see there, so we could even encapsulate them. Right, so the next step then is to build a graphic user interface, or a GUI, or a GUI. So this is this small panel at the top of Max for Live. So this is what appears in Ableton Live. So often this is quite small, it doesn't really give you enough flexibility. So there are many ways to expand this. So we could do certain things like expandable panel, so it starts at a certain size and then expands off to the right, or we can actually open up a pop-up, so it behaves more like a VST in something like Logic, Pro Tools, or whatever. So because of the device that we're doing, I think a pop-up would be the best option. But whilst you've got that pop-up, you should also still have something down in that live panel. Okay, so we'll just put a simple placeholder here. It needs a button on there to say open up for more controls, so on and so on. So the first thing we need to do is just make sure the patch is opening in presentation mode. This is a common fault. So to do so, we're going to go to the inspector, then we'll go to the patcher inspector, which is this P, hit all, and then scroll all the way down to the bottom, and then you'll find in view, open in presentation. So select that, save your patch. Okay, and then automatically your patch will open in presentation mode. So you can see, there it is, saving in presentation mode. You'll notice as well, because there's no extra objects going off to the right hand side, it's also restricted its size as well. So now let's make something that resembles the instrument, so a bass guitar or a bass guitar and an amplifier. So to do this, I'm going to create a nice image, and because we are in the generation of AI, I'm going to use Adobe Firefly just to do some generative image design. Okay, so I'm just going to write into here bass guitar and amplifier. Let's just pick a design that we like, and we'll download this image. Okay, so I've downloaded that and I've put that again in the parent folder of the patch. We can then drag it in and it will automatically create an fpic. Okay, let's resize that. Let's put it where we want it. Okay. Let's just add some annotations. Okay, so you can drag any JPEG in. Okay. It's very important then also, once you've dragged it in, just to open its inspector and tell it to embed image in Patcher. Okay, so whenever you move this file or when you reopen this file, it will make sure that that is saved within it, because again, you don't want to lose routing to certain assets. Okay, so now we need to add this to the presentation mode. So right mouse click, add to presentation, or you can be in presentation and just drag it directly into presentation. But let's just resize it for that panel. Again, save it, let's close, and now you can see there it is, Kontakt style bass appearing with that nice image there. Okay, it's a bit plain though, so I think we need to actually think about what a GI's purpose is. So it's interfacing, so does it need a name, does it need specific controls, does it need specific instructions? So what I'll do is I'll go back into Firefly, and you can see here there is an option to do more with the image, so I'm going to add some guidance text to this. So let's call it bass guitar. Lovely stuff. So we'll just kind of work out a design. There we go, realistic, I like that. It's very Radio Shack. Click here for more options. I'm going to have a pop-up window open button here somewhere. I love the sort of juxtaposed symmetry. Let's put that image in again. Let's add it to Patcher. Get rid of this. Lovely. So now let's move on to the pop-up window. So Music Hackspace have some wonderful courses on Max for Live. So within that, one of those, they have a GUI one. So this is just borrowed from there and adapted slightly, but just some coding to be able to create a pop-up. So what it's doing is it's actually opening up a sub-patch, and it just opens that up with some fixed controls, so it looks like a plugin GUI. So it's all triggered from this open button here. And that just basically sends, using the select, it routes the open and close messages to a P control, which controls sub-patches. And then it just basically pops this sub-patcher up. Now within that sub-patcher there are then more bits of code written that essentially kill some of the controls. So what you don't want when you've got a pop-up, because currently in its current state it will just pop up and you'll open up a Max for Live window with all those extra controls on the top bar, the inspector on the sidebar, you'll be able to resize it, all this sort of stuff, which we kind of don't want, we want to get rid of. So I'll run you through that in a second. So that open button resizes on presentation mode, but you can see this is what it's doing at the moment. So it just pops this window open. And you can see there it is, just popping up. So what's in there is the code that sort of comes preset with that code that's available. So let's look inside this P pop-up. So this is actually where we build our pop-up GUI. So you see there's two dump messages there. There's a dump message connected to the red object and a dump message connected to the grey one. So do not delete either of those. So the dump message connected to the red basically allows you to edit things. So you can see at the minute I can't actually resize this. So the reason is things are locked, and we want things to be locked because we don't want users in live to be able to resize or delete Max objects. So to do this we need to double click that dump going into the red. So click. I've held command as well while I'm clicking, so that actually allows you to do the function while it's unlocked. I can now resize this window. Okay, but as I say, do not delete this because otherwise you end up with a locked patch and you just have to delete it and start it all again. So hold command and then double click that dump, and you can see I can now resize. So again, we want this to be opening in presentation mode because this is where we're going to build our GUI. So again, go to the inspector, patcher inspector, scroll all the way down to open in presentation. Okay, and this then will hide all of these objects here for us, and we're just going to view this. So we can put into here anything that we want as a GUI. Okay, so I'm just going to choose that basic image, and I'm going to add some controls over the top, but you can see I'm just resizing to there. I'm going to add an overlay here, so I'm just going to add a grey overlay, and through the colour here I'm just going to change the opacity. Okay, so that just allows it to have a sort of bit of a darker overlay so that any objects put on top can be seen, can be more visible. So again, I'm just doing this for my own basic GUI, but the way you design your GUIs is completely open. So on here we can add those ADSR controls that we created. So I'm going to use some live dials. Okay, I'll change the colours so they're a bit more attractive. Let's see if I can find some suitable colours. That will do. Okay, we'll rename them all. We'll make sure that they're running on the correct ranges. Okay, so making sure that your sustain is the right value. Things are milliseconds where they need to be milliseconds, and so on. So let's just put these into a nice place so you can lock them and group them if you need to. That's quite fun. Let's just find the right colour. That could be for days. Yeah, that's better. Let's just use a comment there just to label it. Let's put a level meter up as well. So again, we can set the opacity, change that. So here I've just created some sends just so I can send it into the attack, decay, sustain and release. I'm going to take a feed off the main output as well just so I can plug into that level output. There we go. So then my GUI just has a meter in it. So we'll resize it. And we'll close. Oh, I don't think I saved it after I resized it. Okay, go back into this pop-up. Hit dump, resize. Come back out, hit that other dump. That's what I need to do. Oh, no. Go into presentation mode. Now, there we are. Okay, so there's our pop-up. There's our meter working. There's our attack, decay, sustain, release. And there we go. So this is very basic. Obviously, think about what you need to put on for your own GUIs. So if you've got filters, other stuff on there, the world is your oyster. So cool, thank you for watching. Hopefully that's a good bit of guidance on how to make a Kontakt style sampler instrument in Max for Live with a GUI, making use of the pop-up taken from the Music Hack Space tutorials. Thank you very much, everyone.